Hello everyone, welcome to the Gradeup. Jay Kumar, Sri Kumar, very good evening all, very good evening. Come on, join the session. This is the production part 3. Till now we have completed 2 parts for the Vizag Management Trainee Recruitment 2020. And we have started the sessions on production engineering. I am good, Jay. I am good. How are you? So welcome to the Gradeup, the India's largest e-learning platform. Dear students, come on. Ask your friends to join this session. Share this session. Come on, come on. Do join the session very fast. Today the session will be based upon the metal cutting and machining. So I hope yesterday we have completed the metal forming, and before that we have completed the casting, right? No issues, Sri Kumar. You can see the sessions which are available on the YouTube. Come on, join the session very fast. Aa jao sab. So this is about me. I am Onkar, having more than 10 years experience for teaching GATE and ESE. Till now I have mentored more than 10,000 number of students for GATE and ESE examination. And my area of expertise or my area of interests are the production and industrial engineering and the fluid mechanics as well. So shall we start? Shall we begin, dear students? This is the series which is on 550, more than 550 practice question. Okay, that we have promised, and definitely we are moving ahead to achieve those numbers. Satish, good evening. Ramisman, very good evening. Yes. चलो आ जाओ भाई, चालू करें हम, आप चालू करें. Shall we start now? चलो बोल दो एक बार सब लोग. Shall I start the session? So do like the session, share the session, and do follow me on the Gradeup app. Do follow me on the Gradeup app, where you will find again, there will be again a lot of free series which are running every day. Okay, so let us begin the today's session, dear students, which is based on the metal cutting, and this is the first question on your screen. Arun, Arjun, very good evening, very good evening. Come on, join the session and be there till the end. Okay, don't go anywhere. Gangwar, Shubham, very good evening. Fine. So tell me, the first question is in front of you. The reaming is the operation of. So reamer. So why this reaming is used actually? Why the use of this operation? What is the use of this operation? So enlarging the end of the hole cylindrically, end enlarge करेंगे तो it is not the reaming, it is the counter boring. Cone shaped आएगा तो it is a counter sinking. And smoothing and squaring the surface around the hole, it is nothing but the spot facing, that you know very well. So A cannot be the answer, B cannot be the answer, C cannot be the answer. So reaming is what's quite, we are sizing the already produced hole and try to have the finishing on that hole. Yes. So all are there. TNV, yes, TNV Kishore is there in the afternoon session. That is on the additive manufacturing. Yes, TNV Kishore is same guy. Chahat, welcome dear. Naveen Kumar, hi, how are you dear? Yes. So the correct answer is what? Reaming. So related to reaming, what is again speciality? It is having the equal number of fluids, okay, to balancing the cutting forces. That is the reamer. A very little material removal we are having. You are going to just size to the accurate dimension the hole, and to have the finishing of that hole. We are doing this process, reaming or reaming operation. Yes, Sarvan. यस यस, ऑल आर करेक्ट. डी डी दिल्ली, डी दिल्ली द पहला ही हमारा जो क्वेश्चन था ये दिल्ली की तरफ गया है. चलो भाई नेक्स्ट. नेक्स्ट क्वेश्चन. The poor machinability of the centrifugally casted cast iron pipe is due to, yes Ramkisan, to improve the accuracy, required dimensional tolerances, we are having that reaming operation. That is absolutely correct. चलो आ जाओ भाई सब लोग आ जाओ. Like the session, share the session, ask your friends to join the session. Yes, poor machinability of the centrifugally casted component or the iron pipe is due to why it is having the pure, not pure, it's a poor machinability. Poor machinability. Matlab there is not the ease is present while machining the centrifugally casted cast iron pipe. So dear students, as you know that this is the question related to the casting as well as the machining operation. Okay, so casting is also there and machining is also there. So you know the one thing is that very clear is that whenever you look for the microstructure of centrifugally casted pipe or which is made up of the cast iron, say which is iron is the matrix element and the carbon you can have as a impurity, rather you can say. Okay. Now here if you look at the microstructure which is made by the centrifugal casting, so in case of the cast iron we say, so this is white color is representing the say the matrix of iron and the red color I am showing you here the carbon. So microstructure is going to show you the rich in carbon, that is some layer, and some layer which are there which is poor in carbon. Again some layer will be rich in carbon and some layer will be poor in carbon. So this is uneven structure that is going to come out. Okay, so denser, that is absolutely whatever the see material which is having the weight, that will having the maximum centrifugal force and that will go at the outer side, the periphery, and the light material, the light impurities whatever will be there, that can be have at the center, that can be at the center. So here they are asking about the machinability. Machinability is related to metal cutting. So why the poor machinability you are to get the good machinability, material should be homogeneous, having the same property. Here what is happening here? So here if you look at the density of the iron, it is, you know, it is 7.8 grams per cc around. And if you talk about the density of carbon, it is 1.24 grams per cc. And you know that iron is having huge affinity towards the carbon. Iron is having huge affinity towards the carbon. So that is the reason why, because of centrifugal force, no doubt iron will try to go at the outer layer of the pipe, but it cannot completely get separated by the carbon. So what happen? There will be the microstructure which is get created into the material, like this is the C layer which is rich in carbon, and you can say the adjacent layer which is there, which is having very less number of carbon atoms are present, which is poor in carbon. So such a heterogeneous structure, layer by layer structure, microstructure you observe there, and of course this is no more very good sign to have a good machinability. And this phenomena actually, dear students, regarding to this iron, when you centrifugally cast that iron, you will get such a kind of structure is known as the segregation effect. क्या बोलते हैं इसको? This is known as the segregation effect. Because of this segregation effect, dear students, the machinability of the centrifugally casted iron pipe is very poor, Okay, I hope it is correct. I hope you understand the segregation phenomena. What is this segregation phenomena? No doubt iron is having huge affinity towards the carbon. Okay, but because of this centrifugal action, the iron and carbon are trying to get separate, but they are not totally get separate. They will be creating rich in carbon, poor in carbon, rich in carbon, poor in carbon, such a kind of structure, microstructure, and that phenomena is known as the segregation effect. Segregation. See, that is the correct. If you want, you can go and read for this casting, centrifugal casting. So centrifugally casted product is having generally low machinability, poor machinability. The reason is what? This segregation effect. Please, if you have doubt, you can go and read that. Please. Okay, so if you talk about the impurities, so lesser or less dense impurities will be collected at the center, and the high weight, because you know centrifugal force is proportional to mr omega square. So it is proportional to what? The mass, and mass is proportional to volume into density of the material. So higher the density of the material, it will go towards away from the center, and lower impurities will be there. It is not getting safe, that is the thing I am saying, but they are creating the structure like this. Yes, this is correct. I hope you should know this happening in the, say, in the case of the cast iron. When you are centrifugally cast it, they are producing this segregation effect, segregation phenomena they are creating. Please. Okay, so that is correct. So even you don't know, please understand this. Whatever it may be the question is from, you just know the concept first. So Reaming sir, now I have explained you. Okay, now you should change your answer, no? Or you go on research for this, and you can come in the day after tomorrow class where we can discuss it. I hope it is clear. Next question. Consider the following tool materials. Tool materials are given to you. High speed steel, cemented carbide, ceramics and diamond. Okay. So please tell me the answer. So what they are saying, the correct sequence they want. They want the correct sequence. So what is the high speed steel? Up to what cutting speed we are using it? 40 to 50 meter per minute. Yes, Sarthi, good evening. 40 to 50 meter per minute. Then the carbide tools, if you look at, we can use that tool from 300 to 350 meter per minute. If you talk about the ceramics, you can use that tool for the speed of 400 to 500 meter per minute. And diamond, you can go up to 2000 meter per minute. So definitely, if you look at the increasing order of the cutting speed, increasing order they are asking, increasing order. So definitely diamond is having very huge. Okay, and the HS is having very less, that is 30 to 40, then say 300 to 400, 500 and up to 2000. So 1, 2, 3, 4 as it is we can make the sequence. That is the correct sequence will be 1, 2, 3 and 4. So B Bombay is the correct answer. 1, 2, 3, 4. Increasing order they are saying, not in the decreasing order. I hope it is clear. So all of you are there. I hope you know the cutting speed range for each and every tool, right? So HSS 40 to 50 meter per minute, cemented carbide how much? Say up to 350 to 400 meter per minute, ceramics 400 to 500 meter per minute and diamond up to 2000 meter per minute. Yes, 1, 2, 3, 4 is the correct step. 1, 2, 3, 4. B is the correct step. Very good. Or B is the correct answer. Next question. In grinding operation for grinding harder material, you know that in grinding operation generally to have the grinding of the hard material we are going for the soft grinding wheel, and for grinding of the soft grinding of the soft material we are going for the use of hard grinding wheel. That is, you know very well. So only the thing is that here in grinding operation for grinding of the harder material you can use any, because see that softness or hardness is irrespective of the grain size. Okay, you can use any grain size, that is irrespective of the grain size. So actually the logic or the connection is through this. Okay, So only thing is that with the hard material, if soft grinding wheel, soft bond is used, definitely grinding the abrasive grains can be very effectively can replace the blunt abrasive, and we will have, or there will be no any blocking of the chips. Yes. So please remember that any grain size may be used, no such a way. So D is the correct answer. D is the correct answer. Please remember. Please. D is the correct answer. Any grain size may be used, irrespective of the grain size. It is there in the grinding operation. You can have the harder or softer grinding wheel. So D, Delhi is the answer. No such a thing, Chahat. The grade is different thing and grain is different thing. Please don't see, you are confusing. So grain is different story, okay, and grade is different story. Grade is what actually, see, this is related to loading unloading of the wheel, okay. See, here grinding operation for harder material we need the soft wheel. Soft wheel, why soft wheel? So that the material removal is good, and also the grinding wheel which we have there, it can easily the material or the grains which are active grains can be actively they are participating in the machining, and the rest or which are the grains which are coming out to replace these active grains after they become blunt. So this process is so nice or flawless process ये होने के लिए we are actually using that kind of logic, that is soft hard के लिए and soft material के लिए hard grind like that, but it is independent of the grain size. Next, the operation of sharpening a grinding wheel is known as sharpening. That is what we are going to do here. So whatever the blunt abrasives are there, we are trying to remove those abrasives, and now we are making the layer, okay, which is in front of the tool, which is with the new abrasives. That is nothing but what? Which operation? That is kind of, see, whenever our tool geometry get lost, then what we are simply doing, we remove the tool from the machine and go on the grinding operation to give the new geometries like angles, the cutting edges, okay. So same way in the grinding operation to sharpen, whenever the grinding will become blunt, okay, all the active grains are become blunt. So the new layer we are going to give for the grinding wheel by using the dressing. It may generally the dressing is done by using the diamond dresser. कौन सा dresser generally use होता है? There is a diamond dresser where the wheel is rotating with very high velocity, and you are having at very fine or micro depth with the diamond, you are cutting or taking the layer of this blunt grain out and exposing the new grains to have the machining. So this is known as the dressing. B, Bombay is correct. B, Bombay is correct. And tell me what is mean by truing? Truing क्या होता है रे? I hope you know all this. What is mean by truing? So dear student, don't confuse with this truing and dressing. Don't confuse it with truing and dressing. See, yes, star diamond dresser is there. Chahat, very good. You know this. See, truing is again a kind of sharpening operation. But here, see, truing a kind of dressing operation. But here we are trying to give you such a, say, the form that you are going to produce onto the workpiece. Such a geometry or such a form you are trying to build on the grinding wheel, that is your tool. So such a kind of operation, it is kind of the dressing only, but here some form that you are going to produce on the grinding wheel, which form you want to produce on the workpiece. Okay, so that means what we are saying, we are truing, we are make the true shape of the grinding wheel, where the same shape it is going to produce on that workpiece. Okay, so this is the truing. Truing as also we can do with the same dressers, okay, but here only thing is that we are going to give some curvature, we are going to give some form, okay, that means we are truing the wheel. हम ट्रू शेप में लाना चाहते हैं कि जिस शेप को वो प्रोड्यूस करने वाला है वर्कपीस के ऊपर. आई होप दिस इज करेक्ट. ट्रूइंग इज करेक्ट. ओके फाइन. नेक्स्ट क्वेश्चन. Yes, yes, that is correct. Please attempt this question. In which of the following operation on the lathe will the spindle speed be minimum? Yes, come on. Tell me in which of the following operations on the lathe will the spindle speed be the minimum? Come on, answer the question. आ जाओ भाई सब लोग. नर्लिंग ऑपरेशन, फाइन फिनिशिंग ऑपरेशन, टेपर टर्निंग ऑपरेशन या फिर थ्रेड कटिंग ऑपरेशन? प्लीज टेल मी द आंसर. यस, कम ऑन, आंसर द क्वेश्चन. सोनवने, हाय सोनवने. प्रतीक, खड़से इज देयर, शिंदे इज देयर. वेरी गुड. Come on, join this session and tell me the answer. Shri Kumar, very good. Thread cutting, that is correct. Thread cutting, D Delhi is the correct answer dear. Thread cutting is the operation with the minimum spindle speed. With the minimum spindle speed we are carrying out. Okay, thread cutting is very correct. D, thread cutting, that is absolutely correct answer. Next question. For drilling operation, the cylindrical job. Namaskar Pratik. For drilling operation, the cylindrical job should always be clamped on. Please tell me the answer for this question. Collet, socket, jaw or V block? Yes, Dimple. Tell me, for drilling operation, the cylindrical job should always be clamped on. Good evening, Mahesh. Come on, join the session. Yes. So for your yes, it is generally held in or it is clamped in the V block. That is very simple question. It is very simple. Yes, V block is there. Yes, V block. We are keeping this cylindrical job. We always keep or clamp in the V block. So V block is correct. Khadse, yes, Khadse, Mahesh, Arjun, it is D, V block. So it is, yes, it is the V block. Next question. Size of the shaper. Yes, Dimple, correct. Size of the shaper is specified by. I hope all of you know this question. Size of the shaper is specified by. Size of the shaper is specified by. How many degree of freedom are rested, Chahat, in case of the V block when you put the cylindrical block? Check it, how many degree of freedom are rested, and by the drill how many again get arrested. Yes, very good. Length of the stroke. Excellent. That is correct. Sarvan, Jaykumar, Sri Kumar, all are there. Neha, very good. A is the correct answer. So shaper generally specified by the length of the stroke. Okay, in the length of the stroke we'll be having the cutting stroke and the ideal stroke. In cutting stroke we are actually removing the material. In ideal stroke we are actually having from this work surface at some height we are lifting the tool and it is coming to back to the original. Where the no cutting, it is ideal stroke, so it should be a fast stroke. Cutting stroke, it is having the lesser velocity than the ideal stroke. Okay, that you know very well. Length of the stroke, length of the stroke. Next question. The following type of the chip is produced when machining ductile materials. Yes, come on, join the session, dear students, and do follow me on the Gradeup app. Various series are there, free series are there running on the app. You come, always welcome all of you there. Yes, see, continue, see, when you are having the brittle material that you know very well. Dear all, please remember that only I am saying the ductile materials. No doubt continuous chip is classified as the continuous chip with the built-up edge, without the built-up edge. But for that reason, I should have some other parameters also in my hand. Say example, cutting velocity should be there. The value of the rake angle should be there. What speed and feed or what the feed and depth of cut I am using, it should be there. Based on that only I can decide whether it is built-up edge or without built-up edge is there. Okay. No, it is not both ends. It is only ductile material. I only know this limited edition here. Continuous chip is produced. But to say whether it is with the built-up edge or without built-up edge, I am not sure with this data which is available in the question. Please, whenever the additional data, say in case of the rake angle they say something, in case of velocity they say something. Okay. So yes, definitely A is sure 100% correct. For the C, they should give some another conditions also, Dimple. Okay. Say example, if I saying that I am going to use a very high cutting speed. So whenever I am using a very high cutting speed, there is no time to get the chip to get added to the this face. Rake face of the tool. It will definitely, as soon as it is produced, even it is continuous, it will go away from the metal cutting zone. So no time is there. Okay. For example, if I am wearing, I am using a very large rake angles. So what will happen with the large rake angles? Cutting forces are going to reduce. When cutting forces are going to reduce, definitely no additional heat is going to generate in the metal cutting zone. Okay. So definitely temperature is get maintained. Okay, no higher temperature, so no addition of the chip on the rake face of the tool. So continuous तो है ही, but वो adder नहीं होने वाली. I am using the coolants again. So I am keeping the temperature of that metal cutting zone as minimum as possible. So why should there is addition of or welding of the microchips? So all the things. सबसे पहले with built up edge अगर बात करनी है तो there should be a very good force of attraction. That is, there should be a very good adhesion between the workpiece and the tool. That is the first condition that it should satisfy. Okay, fine. So please remember, ये क्वेश्चन बहुत अच्छा है, सबको लगेगा, बट कंडीशंस कहाँ है इसके? ओनली डक्टाइल मटेरियल, इट कैनॉट से वेदर इट इज बिल्ट अप एज होगी या नहीं होगी. सो आई रिकमेंड दिस आंसर ओनली एज कंटिन्यूअस चिप ओनली. ओके. ब्रिटल के लिए तो भाई आपके पास है लो कटिंग स्पीड है, लार्ज रेक एंगल है, लार्ज डेप्थ ऑफ कट है, लार्ज फोर्सेस जनरेट हो रहे. डेफिनेटली दीज आर ऑल, सो दीज आर रिलेटेड टू ब्रिटल मटेरियल के साथ डिसकंटिन्यूअस चिप होगी मैक्सिमम टाइम्स. जैसे ही शेयर होगा तुरंत कहां पे आ जाएगा? ऑन द फेस ऑफ द वर्क पीस एंड गेट सेपरेटेड फ्रॉम द टूल. नेक्स्ट. At high speed continuous chip produced while the low speed, yes, लो स्पीड अगर होगा ब्रिटल मटेरियल के साथ डियर तो वहां पे क्या हो जाता है? कर्लिंग टाइम मिल जाता है. चिप जितनी कर्ल होती है उतना उसके अंदर बेंड हो जाता है. और स्टीप, और याद रखना चिप के अंदर स्ट्रेस नहीं होता, स्ट्रेन होता है. सो डिस्टॉर्ट आसान तरीके से हो जाती है, बराबर. सो कर्ल जितना बेंड जितना होगी उतना कट होगी, और जितना कट होगी वो आसानी से डिसकंटिन्यूअस बन के मेटल कटिंग जोन से बाहर निकल जाएगी. प्लीज रिमेंबर दैट मच थिंग ओनली. Yes, yes. Select the correct sequence. Yes. Tool life is influenced by which one of the following? You know the relationship, the generalized relationship given by the Taylor. Vt to the power n is equal to constant, or more standard form we can have Vt to the power n. The feed to the power p and depth of cut to the power q is equal to constants where p is greater than q. So dear, definitely you can have the maximum influence from the speed first, then feed, and lastly with the depth of cut. So cutting speed 1 number, feed rate second, and depth of cut at 3. 3 1 2 3 1 2 3 1 2. Yes, B Bombay is the correct answer. B Bombay is the correct answer. Come on, join this session. Yes, Pratik. B Bombay. Ramisman, B Bombay is the correct answer, dear. Yes, absolutely correct. In taper turning operation, the maximum and minimum diameter of the job are given by the capital D and small d respectively. What is the taper angle if the job length is L? So you want to produce the taper. You are having capital D here, small d here. Definitely this is a total angle is 2 alpha. So at one side I will take the angle as alpha will be what? This d minus d divided by 2 if take radial. Okay. And the tan of alpha will be what? Tan of alpha will be this d minus d divided by 2l. Okay, but alpha will be what? Tan inverse of d minus d divided by 2l, and full the angle, taper angle, I have to multiply by 2 is equal to 2 times tan inverse of d capital D minus d divided by 2. So what is the answer? Tell me what is the answer now? What is the answer now? It is 2 times tan inverse of capital D minus small d divided by 2l. So A, I hope A is the correct answer. Complete taper angle, when you can say it is 2 alpha is equal to 2 times tan inverse of, now see it is in front of you only, answer is in front of you. Pratik, A, very correct. Yes, 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 tell me the answer. Kishore, very correct. Jai Kumar, very good. Kajale, सारवन काजळे, खडसे साहेब, मुक्ताई नगर का. वाय रिट्रॅक्टेड. महेश शिंदे, बरोबर आहे, बरोबर आहे. येस येस. गंगवार, व्हॉट हॅपन? इट इज करेक्ट, नो? So full the taper angle we have calculated. I hope A is the correct answer only. A is the correct answer. Next question. Orthogonal cutting system is also called as orthogonal cutting system. Orthogonal, where there is the cutting tool and the velocity vector. Cutting tool and the velocity vector are normal to each other. Like this. So you can find here the cutting velocity vector and this cutting edge are normal to each other. So you will find here only Fc and Ft. These are the two components of forces you are having. Okay, one is the main tangential component Fc and one is the thrust force. So it is known as Yes, B, Bombay is the correct. Two-dimensional cutting system, 2D cutting system. Two-D cutting system. I hope it is clear. And oblique cutting system. So again this FT is there, which is perpendicular to the rake face of the tool, having the two components. Okay, that is FT with the major cutting edge angle, that is CS, side cutting edge angle, FT cos CS, and this is FT sin CS. One is axial component will be there and one is tangential, sorry, one is radial component will be there. So there are the forces, how many? FC, then there is a F axial and F radial. So three cutting forces are there in case of oblique. So that is why it is known as three-dimensional cutting. So yes, that is correct. Next question. Quick return mechanism in unincorporated, that is very easy, that you know very well, that is shaping operation only. Quick return mechanism, I told you, in the shaping operation, the return stroke is faster than the cutting stroke. Okay, so that is this, we are using this quick return mechanism, isn't it? You know very well, the shaping machine is the correct answer for this. Yes, shaping is correct answer. Shaping is correct answer. Shaping machine is correct answer. Yes, D. Yes, D is correct. D is correct. D Delhi is correct. Dharnendra, Kumar, Sarthi, Jay Kumar, Sarvan, all are correct. D Delhi is correct. Next question. Yes. Now tell me the answer for this question. For which machines are very large speed range required? Now from looking to the options, you will be very get clear about the options. I am saying that large speed range matlab maximum to minimum speed, n maximum to n minimum. Yes. So in grinding operation, huge speed requirements, huge speed ranges are there. Yes, all are correct. C Calcutta is correct. C grinding chahat, very good, excellent. Onkar, very good. C Chennai is correct, very good. C is the correct answer. Next question. So railway rails, Mahesh Shinde, very good. Railway rails are generally made by yes, that is very huge speed we are using. More than that also we can go. So grinding, it is not having see, generally many of the processes we will see the tangential force to the thrust force ratio is generally 2 or 2.5. But when you talk about the grinding operation, there will be the reverse thing. The thrust force is twice or 2.5 times the tangential, that is cutting force. So that is reverse thing in the case of the grinding operation, where the thrust is very huge. Okay, so tell me the railway rails. So generally, see, please remember, these railway rails we are generally made up of the alloy steels which are containing the high carbon. कितना होता है? 0.8 to 1.2%, or 0.8 to 1.1% of carbon. So here only the range is given like this, 0.8 to 0.9 carbon. So C is a more correct. Yes, C is the correct. Not medium carbon steel, it is an alloy steel which is containing that is high carbon steel, 0.8 to 0.9% of carbon. So high carbon steel, you say, if Shubham, you are saying the high carbon steel, it is from 0.8 to 1.5% of carbon. Which postal package you are talking about, or So anybody knows, then please try to help the Himanshu Sharma. See Shubham, high carbon steel, you are saying that it is from 0.8 to 1.2, 1.3% carbon, it is okay. Okay, but see, typically 0.8 to 0.9, it is the standard thing for percentage of carbon in case of the railway rails. Please remember this. This is correct. Next question. Lathe bed. Oh, don't go for that. I will not take the name. I will not take the name, but don't depend on such a only postal courses, dear. Anything, any a very huge name, I don't bother about it, but just I am saying you. I hope Shubham is having that. Yes, cast iron, that you know, it is having a very good damping capacity, vibration or shock absorbent capacity. That is very good. The cast iron is correct answer. So for this, A is the correct answer. A is the correct answer. So in which milling operation is the surface finish is better? So you are having, there are two milling processes that we can have. Okay. One is known as the conventional milling process, that is the up milling. That is the feed given to the tool and the rotation of the cutter are opposite to each other. And where the feed given to the tool and the rotation of the cutter are in the same direction, that is the climb or down milling. So you can see here where you will get the very good surface finish. Himanshu, then you can, I will give you the contact number. You can contact the Gradeup. We people definitely here to guide you. Okay. Yes, climb and down. See, the up milling process is known as the conventional milling process. Name is only. And down milling process is known as climb milling. Okay. So surface finish, definitely here the chip is actually, complete chip is going to cut at the end of the operation or the end of the rotation. Here at the last we are getting the chip, and that chip is going to move on the already finished part. So that is the thing why the surface finish is get destroyed. Destroyed means it is poor in case of say up milling, but down milling it is better, because at the initial beginning we are getting the chip, so at the end we are having very minimum thickness. Yes, so go with the Gradeup. We are here to help you, guide you. Fine. So climb milling, that is the down milling, is correct answer. I hope don't deviate from our subject. Okay. So climb milling is the correct answer, that is down milling. We are getting the good surface finish, we are getting the very good tool life. Okay, we are getting the minimum forces there, because the wear and tear of the tool is not that much with the case of the up milling, because see here the tool and the workpiece fade oppositely here in one direction. That is the reason. Fine, so that is correct. The tool material which has high heat and wear resistance is. Yes, tell me about this question. Tell me about this question. The tool material which has high heat and wear resistance. Okay, high heat and wear resistance is ceramics, cemented carbide, carbon, or the medium alloy steel? So I hope stop your chatting there. You can see the question and tell me the answer. I have given the option Himanshu. You can contact us. We will guide you. So I will make you clear here. So no doubt the hardness of the ceramics are more than the carbons. Cemented carbide, no doubt. Cemented carbide से ceramic का hardness क्या है, ज़्यादा है, that is hot hardness is there. But if you talk about the heat and wear resistance capacity of the ceramic is more than the cemented carbide. Okay, so that is the very important thing. Chahat, please remember, cemented carbide, no doubt the hot hardness is more. Okay, but high heat and wear resistance capacity of the cemented carbide is more than the ceramic. Where previous question? How? Please remember, tool material which has high wear, heat and wear resistance. Okay, high heat and wear resistance, cemented carbide is good compared to the ceramics. No doubt, hot hardness of ceramics is more than the cemented carbide. But wear resistance, carbides are very good wear and heat resistance they are having. So B is the correct answer here. B is the correct answer. Okay, B is the correct answer. Next question. That known to everybody, the very famous equation, Taylor's two-life equation. Yes, it may be. Yes. That you are saying climb, yes. Climb or down milling, yes. That can be if you have the multiple choice, yes. Climb is also known as the down milling or up milling or conventional milling are same. Yes, that is the thing. Yes, that is correct. That is good observation actually. You can say like that. So yes, the relationship between that is Taylor's very famous equation, Taylor's two-life equation, Vt to the power n is equal to constant. In 1935, he published his all the data. See, the Taylor was very interested to generate the empirical relationships. Okay, so this is one of the empirical relationships that we have. Vt to the power n is equal to constant. Shubham, in this question, what you want, Shubham? So best option is down milling. So forget about this climb milling. These are the conventional names. But here generally we are using up milling and down milling. Up milling and down milling. See. So more if you want, because see these are the optional words are there. We are generally speaking up milling process and down milling. Okay. So वही बोल रहा हूँ मैं, आप जो best option होगा वो really it is the down milling process, down milling. Okay, so because generally we are dealing with these names only. Up milling उसका भी नाम है दूसरा conventional, optional name है या optional name. It is just giving why it is down milling, because cutter is making it is coming like down. Okay, from cutting and it is coming down, so it is down milling. Up milling में क्या होता है, cutter chip को लेके climb करता है, that is up जाता है, so it is conventional, जो regular process है, right? So more correctly you can say it is down only correct. Okay Shivam, no issue. So this is correct. Vt to the power n is equal to constant, V cutting speed, T tool life in minute, n is the Taylor's exponent and C is the constant. During the machining operation, the chips experience stresses. The chips experience the strain. I already told you, a few minutes back I told you this thing. So the chip generally, actually in the cutting operation, the deformed part of the chip, the deformed part of the work, definitely it is subjected to huge amount of the strains. and the deformed part is nothing but in the form of chip. So please remember that the chips are experiencing the huge amount of strains. B Bombay is the correct answer. B Bombay is the correct answer. Yes, Arjun correct, Krishna correct, Shubham. Yes, D cannot be the answer. Stress and strains are not there. See, if you talk about the metal cutting, so we have calculated the shearing strain, that is cot of phi plus tan of phi minus beta. Okay, so in cutting the shear strain are getting generated, and same we are feeling or getting into the chips, that is strain, experience the strains. Chips are experience the strains. So B is the correct answer. The process of enlarging the hole. The process of enlarging the hole. If only at the one end you enlarge it, it is known as the counter boring. Okay. If you enlarge with the conical part, okay, like thing, it is a counter sinking. So only enlarging the already drilled hole is known as boring operation, is known as the boring operation. So C is correct. C is correct. C is correct. Yes. Vannan, Mahesh, Arjun, Sarthi, C is correct. C is correct. Boring, Shubham, very good. Dhirendra Kumar, very good. Khadse, very good. Yes, very good. Next question. The tool life of the tool is said to be over if. The tool life of the tool is said to be over if. The tool has failed and the poor surface finish is obtained. Sudden increase in power, cutting forces, overheating or fuming. So dear students, whenever there are the decision to take that whether my tool is getting failed or not, there are certain things that you are genuinely observe that things. One thing definitely you will observe, the whatever the produced surface finish is getting deteriorated suddenly or not. If it is deteriorating, if suddenly you are getting the poor surface finish, there are chances of your tool is getting failed, over for your tool. Okay. Now second thing, you can observe the cutting forces are suddenly increased, the power consumptions are suddenly increased during the running machining condition. So then again you can say that the tool life is over, my tool is get failed. And the third thing is that whenever there will be the you can see any kind of fumes which is coming out, any kind of white fumes, generally carbon monoxide. Okay, such a kind of fumes you are observing in the metal cutting zone, definitely you can say that something is went wrong and my tool is failed actually. So yes, all these, option A is correct, option B is correct, option C, these are the all correct statements regarding to the giving the clue to us that whether my tool is failed or my tool life is over or not. Yes, A, B, C, all these three statements are correct. So D option is very much suitable, that is all options are correct. Yes, D, Delhi, very nice, all of you are knowing this, so very nice, very nice. Take the next question. The cutting speed is equal to, the cutting speed is equal to, if this is in the chuck, if I am having my cylindrical job with the diameter D, it is giving with the rotation N. Okay, N is what? In revolution per minute I am saying. D, it is in millimeter. So how I can calculate the spindle, the cutting speed VC is the relative velocity with the tool and the job. This is my tool. Okay, moving relative to the workpiece, that is with velocity Vc. Vc is given as pi times d times n divided by 1000. It will be in meter per minute. It will be in meter per minute. Okay. Yes, and if you want to calculate the n from this, sometimes n is required when you are calculating the machining time. So it will be 1000 Vc divided by pi. So dear students, here the suggestion is that whenever you are using the diameter here, okay, generally you should, if you know after doing this machining at what step it is going to reduce, say d dash, after machining this d will be converted to which diameter. So if know this value, you can use here the d average. You can use here d average. Okay, that is d before plus d after divided by. It is very, very correct. It will take you to reality, towards the reality. Okay, Shubham. So I am talking about whether this original diameter you take, or if you are available with the diameter after taking the cut, then you can go for the average. Okay, otherwise no, it is fine. If you are having only initial diameter, you can use the d only, no issues. Next question. Yes, if you divide it by 60, definitely you will get the meter per second. Shrikant. Consider the following statement. In orthogonal cutting, the cutting edge of the tool is perpendicular to the cutting direction. Yes, that is correct. The cutting edge is perpendicular to the direction of the cutting, that you know very well. So this is say perpendicular, you can see here Vc, and this is cutting edge. They are orthogonal to each other. That is correct. Yes, Shubham. Okay, so first statement number 1 is correct. In oblique cutting, the cutting edge and the cutting motion are not normal to each other. This is also correct. This is also correct. Then the majority of the machining operations are based on orthogonal cutting. That is absolutely wrong statement. That is, please remember. Shashidhar, yes, this is for mechanical engineering, dear students who are going to write the Vizag MT 2022 or 2020 examination. So 1 correct, 2 is correct, and the chip slides along there. Chip is slides or move along the rake face of the tool. That is correct. So please remember that, dear students, whichever the operations that we are having, are mostly the oblique cutting operations only. Yes, 3 is wrong. 3 is wrong. So majority of the operations, even you are saying that this is the orthogonal operation. So for the longer time sense, that orthogonal cutting operation is also getting converted into oblique cutting. Please remember this. So please remember, कोई भी ऑपरेशन 100% ऑर्थोगोनल होता है, that is wrong statement. Okay, that is wrong statement. Please remember. So 3 is absolutely wrong. 1, 2, 3. 1, 2, 3. 1, 2 and 4. Sorry. 1, 2 and 4 are correct. So D Delhi is correct. D Delhi is correct. D Delhi is correct. Take the next question. Consider the following statements regarding to the continuous chips are produced. So I hope we already discussed about this. We already had the discussion on this topic, that is continuous chip, how it is going to produce. So only continuous chip, no any discussion on the built up edge. So continuous chip, yes, high speeds are there, ductile material is there. So see, 2 must be there, 2 must be there, that is the theory. Brittle, definitely brittle material, 4 should not be there, that is okay. Brittle material, we are getting the discontinuous chip. So low rake angles, dear students, tell me what happened when the low rake angle is there. In one tool I am having the very huge rake angle, okay, and in one tool I am having a low rake angle. This is the low rake angle, low alpha, this is high alpha, okay. One and two, yes. So with the low rake angle, what will happen? So definitely, see, whenever the alpha angle increases, cutting forces are goes down, okay. Because when alpha decreases, see, when alpha increases, shear angle increases. Please remember how to reconnect these things. When rake angle increases, shear angle increases, dear. और जब भी shear angle cutting में बढ़ता है तो ये बहुत अपने को अच्छी न्यूज होती है. It is a very good news that whenever in the cutting operation shear angle is huge, definitely the cutting is very good. Okay. So please remember, with the low rake angles, the cutting forces are huge. That is, the strains are larger, shear angle is low. When shear angle is large, metal cutting का strain कम हो जाता है. But when the alpha is low, shear angle is low. But when shear angle is low, the shear strain is high. And when the shear strain is high, the forces are very huge. And the forces are very huge, so there are chances to have to break up the chip. Okay, it will lead to the discontinuous chip. So please remember 1 and 2. Yes. What I explained you just keep it in mind and apply the same. You will see at this question particularly 1 and 2 are correct. 1 and 2 are correct. So C Chennai is once again the correct answer. Primary tool force used in the calculating the total power consumption in the machining is. Next question. Tell me the answer. If you look at the tool here, this is a workpiece and we are having the tool here. Okay, so this is the thrust force, we are having Ft, feed force, and this is the tangential component of force, that is our Fc, tangential. Cutting force is there, okay. Or simply when you see the diagram like this, okay, so we are having this Fc and this is the Ft. Okay, so we are not taking this axial force, okay, because you know total power will be what? Fc Vc plus Ft into feed velocity, okay, which is in meter per minute. Okay, so definitely it is, if you have the product of this, it is very less. It is the value of this product is very less. It is not going to affect the big thing here. Okay, so that is the thing, is that you are using the main tangential component of force, or simply you can say the cutting force, that you are going to use in the calculation of power or work done in the metal cutting operation, which is equal to Fc into Vc. So B Bombay, Dhirendra Kumar, what you are saying? I hope it is clear. B Bombay is the correct answer. Okay. So this is the last question we'll discuss and we'll stop. In orthogonal cutting, shear angle is angle between, that you know very well. Shear angle. So this is the shear angle phi, which is the angle between the cutting velocity vector you can take, or the shear plane. Okay, shear plane and the cutting velocity vector. A is the correct answer. A is the correct answer, isn't it? This is the shear angle phi. So A is the correct answer. Yes, A is the correct answer. A is the correct answer. Yes, Arun, Kishore, खड़से, शुभम, दो शुभम वहां पे है. A is correct. A is correct. So I hope it is okay, dear students. So today we have a discussion on the questions, okay, on the metal cutting. Yes, Jay Kumar, Mahesh Shinde, Arjun Raju, very good, very good. Ramishman, very nice. So I hope this is all clear. Tell me the question, tell me the answer for this question. Which of the following indicates? So I hope take it as homework. This is homework number 1. Okay, take this question as homework. Machinability. Okay, which of the following indicate the better machinability? The machinability is nothing but the ease with which the machining can be done. It can be measured with the shear angle. It can be measured with the cutting forces, energy, surface finish, tool life. So all things are here in the question, but just tell me the correct answer. This is the homework. Tomorrow, dear students, we will be discussing, not tomorrow, day after tomorrow, that is on Monday, we are going to discuss the chapters from the metal cutting. That is, we will be discussing some of the questions from welding, some of the questions from material science, some of the questions from metrology, and if possible some of the questions from industrial engineering. Okay, so the mixture will be there and in the last session. Okay, so dear students, see, Gradeup Super has launched these courses, the Gear Up and Rank Up 2021. Okay, these are the ideal courses. Who want to revise the entire gate, the Gear Up is very suitable for that guy. Who want to just repeat for the score improvement, he just want to repeat the course, the Rank Up is there. And dear student, the very excellent the course we have launched, that is the Vision 2022. The students who really want to write the ESC and GATE 2022, okay, who are at the moment in the second and third year, like this one candidate was there, Harshit, no? Okay, so for those candidates, this Vision 2022 is excellent course. You can see the course detail. Any query if you have, you just contact us on this number. Your all the doubts, your all the queries, your all the questions get answered here, right? So these are our star faculties from the Gradeup. Thank you, Ramishman. Thank you so much. And these are our achievers. See it here in top 100. These are our Gradeup achievers. So see, tomorrow, day after tomorrow, we will be meeting. There will be the welding. There is a combination of welding, material science, metrology, all the things I can able to mix. I will mix it and we'll discuss it together. Thank you so much. Thank you so much. And do follow me on the Gradeup app. Okay, do follow me on the Gradeup app. Like this session and share this session among your friends. Till then, thank you so much. Bye bye. Good night. Take care.